So this problem is about how to use the node voltage analysis when the system has a current and voltage source. So example 4.3 and 1. So the figure looks like here, and the problem is required to determine the V1 and V2. So V1 is V2 is kind of a node voltage. So at first we need to check out what kind of node here in this circuit. So I think this will be kind of a big node here. It's node 1. And let me name 1. This is node, okay? And this is also node, and this is a node. So there will be the four node. And among them, you can choose that is a kind of a reference node. So there are 3 node voltage which can be defined. So as following the problem, we will use same notation. That this node we call node voltage V1, and this node we define the voltage V2. And I decided to define this node voltage V3. Actually, there are 2 sources. And the first thing is this voltage source. The second thing is the current source here. Unfortunately, because of this voltage source, we get a V3 exactly 6 volt. Anyway, this is a way how to use the voltage source when the system has a voltage source here. So we can get the VC is actually we need more space, so we'll do it here. Okay. So V3 is 60 volt. So V1 and V2 need to be calculated here. So what should we do? What should we do? First, element current. We should define the element current. So I define the current as this is I1 and this is I3 and this current is I2 and this current is I4, and that's it. So I want to calculate the current. Maybe you have a question about how many current we should define at this point, and why we need to think about why we should define the element current here. Our purpose is to make a node voltage equation. Node voltage equation is from the KCL at their own node. So we should know the current, what kind of current, to make a KCL. So we have this node, we make a KCL based on this node. Then we should know about this current and this current and this current. And to get a KCL based on this node, we should know this current and this current and this current. So we need to define the current to make a KCL in here. So we should define this current is I1, this current is I2, and this current is I3. And to make a KCL, you can define this current, this way is this current, and this way is A4, and this way is defined by the current source. So we don't need to define the current here. So that's the reason we have to define the element current. Then we can identify what kind of limiting current should be defined in this problem? Okay, so what is I1? I1 is maybe V1 is defined here, so based on here. So I1 is V1 divided by 50, because this is a 50 ohm. How about I2? How about I2? I2 is current going from this point 1 and those 3. So we need to define this. This is V13. What is a V13? V13 is, this is a V1 and this is V3. So that will be V1 minus V3. So V1 minus V3 divided by 80 ohm. And here V3 is already defined as 60. So that will be 8 V1 minus 60. And what is I3? I3 is current going through here. So this current. So this is V1 and this is V2. So that voltage is V1 minus V2. So V1 minus V2 divided by 65. And I4 is this current. So this is a V2 and this is V3. So voltage difference between here is V2 plus minus V3. So there will be V2 minus V3 in 75. Okay. What is your second step to make a node voltage here? Node voltage equation, that is using KCL for every node. At first, node A, node 1. Then we can define the current. I choose the current going out from the node, the positive, or I choose the going into the node is a positive direction. So that depending on you. But in my case, I like to make a decision to when the positive means going into the node. So I1 is going out. So in this case, minus I1. I2 is going out from 1 is minus I2, and I3 is going out. So I3 is 0. Because there is I1 plus I2 plus I3 is the same, 0. So I1 and I2 and I3 gap here. So we can make an equation. I1 is that, so we'll use that. V1 divided by 50. I2 is 80. V1 minus 60. I3 is 65. And V1 minus V2 is 0. So next is second node here. So I also make a node KCL. So I decide to choose the positive position is going out, going into the node here. So I3 is going into the node, so plus I3, and that current is going into the node, so plus 0.1, and I4 is going out from the node, so this is the minus I4 will be 0. There's a KCL at the node 2. So I3 is that values is 65 and V1 minus V2 and plus 0.1, and I4 is minus 75 and V2 minus V3 was 60. 60 equals 0. So how many unknown variable here? So 2. What's that? V1 and V2. And how many equation based on 2 variables? 1 and 2. So 2 unknown variables and 2 equations. Then we can get our values V1 and V2 respectively. That's a way how to solve the circuit using the simple the node equation. We call this equation and this equation is, we call that is a node voltage equation. Okay. The next problem, the problem is example is 4 and 3 and 2. So also this program asks us to define the voltage, node voltages VA and VB. So as you see, we need to check what is the circuit. So how many nodes are there? Maybe this is one shoes node here, and that will be a node, right? Because of that, there are different element. This one is connected through this point, and this will be a node. So there are 3 nodes. So this is 3 node, and I choose that node is a reference node. We choose there is a reference node. So we have 2 unknown node voltage. So we need 2 node voltage equation. This is your target to solve this problem. So in the problem, they define that is node A and that is node B. So we can define the node voltage VA is a voltage A based on the load reference node, and node B, the node voltage VB is a voltage difference from the reference node to that node B. Then actually we need to make a KCL at every node, but because of the voltage source, we cannot calculate this current here. So in this case, we can use the supernode here. So A and B could be a supernode. Because there are, between the only voltage source, then you can use there is a supernode. Because supernode is kind of a node, so we need to define the current. Okay, this way, and this way, and this way, and this way is a current source. Current going into the node. So we need to check this current, and this current, and this current. Fortunately, because of current source, we already know the current here. What is that? 1.5 amperes. Then this current is known because of the current source. There will be 3.5 amperes. So I like to choose the current here, that is IA, and that is IB. Why we choose the direction of IA and IB? Because I like to use the Ohm's law, because Ohm's law depends on the passive convention. So VA already is defined in this way. So I choose the positive current direction IA is in this way. The same reason IB direction is here. This is my preference. Then we can make an equation here. Okay. At first, what should we do? That is an element current. Then we decide to define the current here. So IA will be the current going through here. So voltage difference is VA divided by resistance 6. And IB here is VB divided by 3. That's it. And second step is KCL based on each node. So at node A and B is supernode. Then what is the KCL? Is this current is plus 1.5. 1.5, and this current is going out from the node, so there will be minus IA, and this current is 3.5. Is going out from the node, so minus 0.5, and this current is going out from the node, so minus IB is 0. Then you can make equations. Here is IA here, IB here, so minus 2 minus 6 VA minus 3 VB will be 0. That is one equation. Then we have how many unknown variables here? VA and VB, two unknown variables. But because of supernode, we can get only one node equations. So we need more equation to solve the problem. Then what should we check? That is supernode. Because supernode is defining the voltage source here, so we have one hint. What is that? The relationship between the node A voltage, node B voltage. So what's the meaning of that? Because of these relations, this is A and this is a B, and their voltage difference here 12 volts. This voltage node voltage VA, this node voltage VB. So VB is VA plus 12. So this is another equation. So we have two unknown variables, and 1, 2. We have 1, 2, two equations. Based on that, we can calculate VA and VB. The solution will be depending on you. Solution I will give you. So that's very simple. So actually, based on KCL and KVL, we can analyze this electric circuit. But to do that, we should define the unknown variables before, and we need to check the equations based on the unknown variables. Then this node analysis method, the node analysis technique is kind of a method, is give us how to start to define the unknown variables and how to make equations based on the unknown variables. That's kind of the method, the two analyses in the electric circuit. This is another node voltage analysis with current and voltage source. There is example is 3.4.3 and 3. So also they require the node voltage here. So we need to check it. It's very simple. It's not difficult. So at first we need to analyze the node status. Maybe there will be one node here, right? And this will be a node. This is one node. And this will be another node. This will be node. All right? So there will be 4 nodes. Then I choose that node is a reference node. So we have 3 nodes. That means 3 unknown variables and 3 equations. So that's the way how to solve the problems. But fortunately, we have several voltage source and current source, especially the node in A and C is connect with only one voltage source. In this case, we cannot define this current here. So I decided to use supernode in this way. Okay. Then what should we do? The first, what should we read? Element current. Why we need to make a element current? Because we will use KCL. So the current is defined here, right? Because of current source. Then we need to know about that. So we define this current is I1. And we need to know about that. This is I2. Then this current is known because 2 ampere. But how about this current here? Actually, we should know. Why? We want to make here, we want to make a KCL to get the VA node voltage VB. So to get a node voltage VB, we should know about this current. But fortunately, because of a voltage source, we know the VB. So we don't need to know about this current. So we will not define the current over here because VB is known based on this source. So I will not define the current here. So that node voltage VA, then node voltage VB, and then node voltage VC, and I1 will be, then this situation is because current direction is here, so I would like to put it here. So VA minus VB, and I2 will be 40, and because the direction is here, so I like to choose the voltage in here. So VC minus VB. But what is the VB? What is VB? This is important. The direction of the polarity of this voltage source is this is positive and this is negative. So that means that point is lower than 12 volt compared to reference volt node. So VB will be minus 12 volt. So then I1 will be 10 VA plus 12. I2 will be 40 VC plus 12. Then what should we do next? Next is KCL at every node. There are, how many nodes are there? Actually, because we don't need to get the node equation based on VB. Why? We already know the VB. So the remaining node is a super node here. So what is the current going to the super node? At first, this current is plus 5. And how about this? This current is going out from the node, so minus I1. And how about this I2? It's going out from the node, so minus I2. And how about this node? It's going out to minus 2 amperes. Minus 2 amperes would be 0. So I1 plus I2 will be 3. So we insert the values here. 10 VA plus 12, 40, which plus 12 will be 3. So based on there, we will multiply by 40, and then we get anyway, that will be a kind of equation, right? But how many unknown variables are there? We have 2 unknown variables, V and VC. And how many equations? We have 1 equation, that is node equation. So we need more equation. How can we get? From the supernode. Supernode define the voltage relation between VA and VC based on the voltage source. That's the reason why we have to define the supernode in this way. So this is plus and this is minus. This is a VA and this is a VC. So based on that, we know VA is VC plus 10. So we obtain another equation. So we have 2 unknown variables. We have 2 different equations. So we can calculate VA and VB simply. So it's very simple. It's not difficult. And if you have some exercise, then you will get a very strong and powerful technique to solve the electric equation based on these node equations. Next chapter is chapter 4, the node voltage analysis with the dependent source. until now, we will discuss about how to make node voltage equations, especially if there are several independent zones. Then we can use supernode. The reason we use node voltage equation is so we need to specify the element is voltage or current. So the same approach is applied when the electric circuit has the dependent source. So actually, the dependent source is a function of the node voltage. So this is a key point of the dependent source can be expressed as a function of node voltage. I will give you a simple example about that. So this is a key point here. So this is example 4 and 4.1. So in this problem, we need to determine the node voltage for the circuit. The first, we need to check how many nodes are there. So there are one node here, and this will be node. This also will be node. This will be node. So there are 4 nodes. So and I'd like to use there is a reference node. So then we define this node A and B and C, and node voltage is VA is from here. And this is node voltage VB. This is node voltage VC. So because there are 4 nodes and one node is no reference node, so we have to find out the 3 node voltage. So we have to get the 3 node equation. So what should we do? At first, we should make what should we do? Okay. We should make the element current at first. So at first we should define element current. Then in the check what kind of current we should define here. So at first this is Ix from here, and we don't need to get that current because of the current source we can define it here. And we need to know the this current here. I want to define the current name is I1. Then how can you define here? Actually we cannot because this is a source, so we cannot define here first. So Ix, the current going through here is 6. That is VA and VB because my direction of the Ix is here, so that will be the plus and minus. So VA minus VB. And I1 will be the current in this way. This is VB, and this because of the direction here. So this is plus minus the direction of the here. So there will be 3, and plus point is VP, and minus is VC. So VB minus VC. Then, unfortunately, we have some values about that. What is that? VA is same with that values, 8 volt. And VC is the same value over here. VC the same value is 3 Ix. And what is Ix? Ix and this. So 3, 6 VA minus VB. That will be 2 VA minus VB. That is a VC. Then we know about that here. So right in here. Then to A minus VB root 4 minus half VB. So we have three unknown variables, VA, VB, VC, but based on here, we already know about VA, and remain unknown values VB and VC. So we need node to that, we need node to VC and VB. So VC, VB is two unknown. So how many equations we require? We need the two equation we need because we have two unknown variables. Next, what should we do? We need to do KCL for each the node. Because node A has the independent voltage source, between the node A and node reference. So we don't need to have the node equation about the node A. The reason to make a node equation is we want to know the node voltage, but because of thanks to this independent voltage source, we already know the VA is 8, so we don't have to do that. The second node is node B. Node B. In the case of node B, there are three current. So I would like to make the KCL, apply the KCL to the node B. So this contains IX. In my case, I prefer to choose the going into the node direction is a positive. So because IX going into this way, so plus IX. And how about this here? The two arms go up to the B, so plus 2. How about this? I1 is going out of the node B, so that indicates minus I1 will be 0. Then what is IX? YX is these values. So because this is A, so IX is 6A minus VB plus 2 minus I1 is 3 VB minus VC. Okay, here. And how about node C? Can you make a KCL for the can you apply the KCL for the node C? We can't. Why? Because one node is connected through the voltage source, so we cannot define this current. So we cannot do that. Instead of that, we know about the equation of VC related to the other variables like VB. So we have two unknown variables, and we have another variable here. What is that? VC is 4 minus half VB. So we have, and adding here, and we have one equation. Oh, I'll drop it. This will be 0. So we have this equation and this equation. So based on here, we can calculate the VB and VC respectively. That's the way how to solve the voltage electric circuit based on the independent source. The next example is about the problem they have the dependent source. So in previous problem, the dependent source is connected to the load, then the reference node. So we don't need to use the super node in this case. But when the dependent source is connected between the two node, not the reference node, then we should apply. What should we do? We should apply the super node in this way here. So we can do that at first. First, I want to check how many nodes are there. This is node 1, this is node 2, and this is node. There are 3 nodes. And I'd like to choose that is a reference node. So remain, we have two nodes, that means two variables, two unknown node voltage. And so we need two voltage equation, node voltage equation, node voltage equations. Well, there are, but between two nodes, there are dependent sources here. In this way, then we can design a supernode here. So, first, what should we do? We have to do. What should we do? First, the element current. Because we will use supernode, then we should define here. Then in problem, there is X. So I define this node voltage VA, and this node voltage VB. Then current here is IA, and current here is IB. So IA is VA divided by 4, but the VA is inverse of Vx, so that will be 4 minus Vx, and VB is and the VB IV going to in this current is VB divided by 10. Then what should we do? Second is Ch04 supernode. Then first, the current in this way, in this bridge is go up to node A is 3 amperes. So plus 3, and IA is going out of the node A. So I like to choose minus IA, and this way we will also going out of the node, so minus IB will be 0. So I insert that values here and here, then 3 minus VA divided by 4 in minus VB over 10 will be 0. So from here, you can calculate the 120 minus 10 VA minus 4B will be 0. Okay, we have one voltage equations. We have how many unknown variables we have? V and VB. We have two unknown variables and one equations. Then we need more equation. How can get the equation? That is from the supernode. Supernode defines VA equal VB plus 4 Vx. And what is Vx? Vx is minus VA. So VB plus 4 minus VA. Then 5 VA will be V4. So this is another equation that is from the supernode. So one equation based on the supernode and one equation from in the supernode. Two unknown variables, two equations, then we can get the VA and VB respectively. That's the way how to solve. Now the dependent source is a kind of to be the supernode. Next example is 4 and 4.3. There is another example. There is a dependent source, but the dependent source is not voltage source. This is a current dependent source. So you can use the same sequence. The same procedure to analysis the electric circuit based on node voltage. At first, I'd like to check how many nodes are there. This is node, right? Wow. This is node. And and this will be node. And this will be node. I mean, there are how many nodes are there? I mean, there are 4 nodes. I'm sorry, it's 3 nodes. So I will choose this is a reference node. So there will be reference node A is a reference node, and B and C. I choose the name is a C. Then to make the load current here, so we need to check what is the element. Current. Because of this source, we don't need to check. We don't need to consider the node C, because the VC will be 6. We got it from the base on this independent voltage source. Then we need to know about the VA and VC. Actually VB, because VA is 0. So I can do that. But in this problem, there are several. One special things. This line, there are some current. There are some current IA, but the voltage dependent current source here, its current is proportional to that current. So we need to know especially this current. So to know about this current, we need to make a KCL node here in this point. So I will check that current is I1 and that current is I2. Then I1 will be 10 VA minus VC will be 10 VA minus 6, because VC is a 6. And we know that how much VA? VA is 0. So there will be 10 minus 0.6. How about I2? I2 is the same with this current source. How much is it? 5 IA. And this is IA. So then we'll do the KCL at node A. In this A way, then how much is it? Minus I1 minus I1 minus IA minus I2 will be 0. Then I1 is minus 0.6 minus IA. I2 is 5 minus 5 IA will be 0. So 6 IA will be 0.6. Therefore IA will be 0.1. So then we can check the VB because IA 0.1, then we can get I2 is 5, 0.1 will be 0.5 ampere. So we define I2 is in this way, I2. So that voltage difference is VAB divided by 20 will be I2. I2 means 0.5. Therefore, VAB will be 0.5 multiplied by 20 will be 10. Then what is VAB? VAB will be VA minus VB. Then VA is 0. Why? VA is connected to the reference voltage. So 0 minus VB will be VAB. There will be 10. Therefore, VB is minus 10 volt. That is way how to solve the circuit with the dependent the voltage source. This is chapter 5, 4.5 is another technique to analysis the electric circuit. That is a mesh analysis. So in this chapter, I will give you two techniques to analysis the electric circuit. First thing was node voltage analysis. Okay, sorry. First is node voltage analysis. The another technique is mesh current analysis. That's a kind of a dual. So, to analyze the electric circuit, we should define the voltage and current of the element. So the node voltage analysis, at first we define what? Define V voltage, node voltage. But in the case of mesh current analysis, we should define mesh current. And apply the law. What we apply? We apply KCL for node. But in this case, we apply KVL for each mesh. So what is the result? The result is the node voltage equation. Then in this case, we get the mesh current equations. Based on that equations, we can calculate mesh current, then analyze other elementary voltage or current. That's a way how to analyze in the electric circuit. So in this method, they give us a kind of a guideline or sequence or process to analysis with the base of the KVL law. So this chapter will give you the second analysis method, this mesh current analysis. So first, I want to give you a definition of mesh. What is mesh? Mesh is a loop that does not contain any other loop within it. So that is a mesh. Like, this electric circuit, but that would be a mesh here, and that would be a mesh here, and that will be a mesh, and that can be the mesh. And how about this? That can be also be mesh, and that would be a mesh, and that can be mesh. That's a mesh, but that could be mesh. But when you use mesh current analysis, the rule is to define the mesh does not contain any other loop in it. So if you design that will be a mesh, then in it there will be another loop here. So that will lead to problems. So in this case, we does not call this is not mesh. Mesh is defined only a loop that does not contain any other loop here. So based on this definition, that cannot be mesh. Why? There are several small submeshes in it. So in this case, we does not say this is non-mesh. Okay? I will give you very important things. Mesh does not contain any other loop in it. That is very, very important. Then, what is the mesh current? Mesh current means the current through the element constituting the mesh. So we can say that mesh current we define is I1 this way. And that will be, we define that is I2 in this way. So the important thing is, mesh current is not same with the current flowing the specific element. You know, if we design the I1 is in here, I2 is here, this mesh current, then in the case of R1, in this case of R1, the current flowing to the R1 is I will be same with the mesh current I1. In this case, current going through this element is the same with the mesh current. This is in the case. But how about these R3? In the viewpoint of the mesh number 1, the current going through the R3 is I1. But R3 is not only the component in mesh 1, but also component of mesh 2. So in the viewpoint of the mesh 2, the I3, they are current flowing the I2. So current flowing I3 will be I1 minus I2. So I would like to say mesh current is not same with the current flowing through the specific element. The current flowing through the specific element is not the mesh current. It's a kind of a function of a mesh current. That is a very special things, very important things to use mesh current analysis. So I will give you how to make the mesh equations. It's the very same ways as very similar way to make the node voltage equations here. So first thing is express element voltage, not current. In the case of node equation, you should express element current. Why? We need to make a KCL for each the node. But in this case, we will use the KVL in every mesh. So we should define the element voltage as a function of mesh current. Then we will apply the KVL of each meshes in the circuit. This is important things. Mesh current is not same as element current. There will be some case mesh current is equal to the element current when the specific element is included only one mesh. Then the current flowing the element is the same with the mesh current. But element is consisted in the two or three other meshes. Then the element current is a kind of a function of the mesh current, including the element. Then here, there are some element here. I don't know what is that. There will be the resistor or the voltage source or current source, or actually it could not be current source anyway. Current source and capacitor, inductor, whatever it is. But there, I don't know where is the mesh, but there will be mesh 1 is current flowing into here, and mesh 2 is current going through this way. Then I'd like to choose the current, the real current flowing to this element is in this way. Then the current will be a function of I1 minus I2. And if the element was the current source is 3 amps, it's an independent source, Then I don't know the value of the mesh current here, the I1 and I2. Anyway, because there is the independent source, the current here is a function of, I want to define the current here. This is I1, I2, I1 minus I2, because this is element current, but this is element current. So this is I1 and this is I2. The current flowing here is I1 minus I2. Then that will be minus 3. Why? There is a current source here. In the same way it is here. So the V is IR. We define the I in this way because this positive value is defined here. So that will be R I1 minus I2. Okay, I will give you some example of that. So this is example. There are two meshes here. This is first mesh here, and the second mesh here, and we need to define the mesh current first. So as you see, we define this current is I1, and this current is I2. Then we should define the element voltage in each element. And I'd like to define the voltage here. I like this V1, and I like to define this V2, and I like to define this V3. Then what is V1? V1 is R1, and current going through this element is only mesh 1. So I1 is going here. So this is I1. And what is V2? V2 is the voltage is resistor 2, but this element is included in only mesh 2. So current the flowing through this R2 is only I2. So V2 is R2 I2, and the direction is I2. Same with the positives and passive conventions. And what is the VC? VC, because R3 is included in two meshes, mesh 1 and mesh 2. So current going through this way, current is I1 minus I2. So there will be R3 I1 minus I2. Second step is make a mesh equation by KVL. So we need to check the first node and first mesh 1, then there will mesh 1. So I will start here. I will define here. Okay. I will start here and go to the same direction of the mesh current here. Just because we defined one mesh current is in this way. So I will start here. Then I am at what? Minus Vs. So minus Vs. Then I am at what? V1, but plus V1. So plus V1. And I am at V3. The plus V3, so that will be V3 will be 0. Then we can do that. Minus Vs plus V1 is R1 I1, and V3 will be here plus R3 I1 minus I2 will be 0. Then how about second mesh? I will start with the same things here. This is a 3. I will start here. Then I met what? I met V3, but minus V3. So minus V3. And I met what? Plus V2. So plus V2. As you go meet the end of that, there will be 0. Minus V3 is minus R3 I1 minus I2. And V2 is plus R2 I2 will be 0. Then how many unknown variables are there? Because we define two meshes, we have two unknown variables. What is that? I1 and I2. And how about the equations? We got that and that, because because R1 and R3 and Vs is a kind of parameters in the circuit. So with that values, you can get I1 and I2. Actually, if R1, R2, R3 is 1 ohm, then I1 will be 2/3 Vs, I2 will be 1/3 Vs. That's the way how to use that. Then we can get, actually we don't need to the mesh current. What we want to know is a voltage or current. So based on this mesh current, then we insert here. We can get a V1, and V2, and I3, and we can get a current. Here is whatever it is. That is the way how to solve the logic circuit with mesh current analysis. This is another example of mesh. So, let me check this circuit. There are 4 mesh here. This is mesh 1, and mesh 2, and mesh 3. When define the mesh, we need to define the direction of here. This way, in this way, in this way. Then we should define the element voltages, because we will apply the KVL. We need to know all voltage. We need to define the all voltage of each element. So I'd like to define this voltages. I like to do V1. I like to define it like V2. And this is V3, and this is V4, and this is V5. Then I can choose it. V1 is R1, this is plus values, and I1 is going here, so I1. And V2 is the same way. This is R2. There are only mesh 2's current, I2, and V3 will be R3, I3. How about V4? Here, these are plus values and current. Because this is positive. The passive convention. When say V equal R4 and current, but current is defined in this way. So there will be R4 and I1 minus I2. And how about the V5? V5 is R5, but current is defined in this way, in this direction. So this is the same with I2. So plus I2, and this is a positive value, positive direction of I3 minus I3. That is the way how to define the node voltage here. Okay, second step is make a mesh equations by KVL here. So first we need to that. What is the mesh 1? In the case mesh 1. Mesh 1. Okay, I will start. I will eliminate this here. Okay, I will start here, and I made at first I made Vs, but there will be minus, so minus Vs. I made V1. I made plus V1, so plus V1, and I made V4 and plus V4, plus V4, and go to the start point. There will be 0. So Vs equal V1 is R1 I1 plus V4 is R4 I1 minus I2. What's mesh second? Mesh 2. So I will start here. I made minus V4. Minus V4. I made plus V2. Plus V2. And I made plus V5. I made a start point will be 0. So minus V4 is minus R4 I1 minus I2. And V2 is plus R2, I2, and V5 is plus R5, I2 minus I3 will be 0. Then you will use mesh 3. That is, I will start here in this way here. So I will start here. Then I made minus V5. So minus V5. I made plus V3. Plus V3. I made what? Plus VG. Plus VG will be 0. And V5 was minus R5, I2 minus I3. V3 is plus R3, I3, and VZ plus VZ is a kind of constant values. It is given by problem. Then that's it. So how many unknown variables are there? The unknown variable is I1, I2, and I3. How many equations? 1, 2, 3. 3 unknown variables, 3 unknown, and 3 equations. Then we can solve the problem here. So that's way how to solve the mesh current. But actually we need is not mesh current. We need elemented voltage or elemented current. If we want to know the current going through the R4, then what should we do? At first, we can get a V4 here this way. And how about the current? The current going through the R4 is not I1, not I2. Right? The current is I1 minus I2. Based on these equations, we can calculate I1 and I2. Then based here, you can get the current going through the R4. That's the way how to get the element voltage current based on the mesh current analysis. And these equations, we can express that term is like a little bit different. For example, based on here, we can express that is this I1 and I1. So we can simplify that is R1 plus R4 I1 minus R4 I2. How about this? In this case, R4 I1 minus R2 R4 R5 I2 plus R5 I3 will be 0. They will be 0. And this is another things. So from the equations, we can express that is like a kind of the matrix. R1 plus R4 minus R4 0 and R4 minus R2 R4 R5 and R5 and 0 R5 minus R3 R4 and I1 I2 I3 will be Vs 0 Vg in this way. So based on the matrix, so we can get the mesh current very easily. So as I say, the mesh current analysis the electric circuit analysis techniques. There's a dual about the node voltage analysis. So they define the mesh current at first, then we'll use each mesh's KVL. So to apply the KVL, we need to know about all elements, the voltage. So we need to define the element voltage, and second, we will apply to every mesh. From there, we get the unknown mesh current and the unknown mesh current basis the equations. Through the equations, you can get the unknown variable, the unknown mesh current. Based on, we can recalculate the current of voltage of each element. That's a way how to use mesh current analysis.